my talk today is going to be about getting started with open science. So the way I'm trying to pitch this is as a bit of like a getting started guide with plenty of links to further resources and things that you can look up and read up on later. If you're interested in making your science more open, whether that be through open data, open access publication, open source software, or a combination of all of these. Right, so I got my my Twitter, and I just recently made an account on Mastodon because of reasons of billionaires purchasing Twitter. So yeah, if you feel free to give me a ping on any of those if you ever want to have a chat, or through email or any other mode of communication. I'm always happy to chat. Okay, so first I wanted to say a little bit about who I am. So I'm originally from Brazil, more specifically from the state of São Paulo, from this little town here called Botucatu, which is in native indigenous language, it means the city of good air. And that's because it's on sitting right on top of the Paraná flood basalts. So we're right at the edge. So there's a big sheer drop off there. So we get actually pretty chilly winters for Brazilian standards. Right, so I did my bachelor's in geophysics at the University of São Paulo, which is this big gray blob there. And after that, I went to do my master's and PhD also in geophysics in Rio, which is all the way over here. And that's where I stayed for about 7 years or so after, as I was working at the State University of Rio in my first lecturer job. After that, I did a postdoc in Hawaii, working on the generic mapping tools. And after that, I got my job here at Liverpool, and I've been here since about 2019, mid-2019. So just under 3 years now. So as part of an academic job, and like almost all academics, I wear several different hats throughout the different things that I do on my day-to-day basis. So first, there's my research hat, right, in which I do mostly inverse problems in gravity and magnetics. So everything from 3D modeling, 3D inversion, and also inverse problems for data processing, mostly for gravity and magnetics with global and continental scale applications. I'm just recently starting a collaboration with the University of São Paulo, where we're trying to apply some of these large-scale methods to nanoscale magnetic microscopy data, right? Which is pretty exciting. It's a very new field for me, so I'm hoping to have something to share about that soon. You can find out more about that on this link here on the CompGeoLab, which is the research group that I've been trying to get started here. And if at any point during this talk, if you have a question or you want to know more about something, you feel free to post in the chat or interrupt me at any time. I'm more than happy to do that. And I'll also put a link in the chat here in the Zoom chat with a link to these slides. So if you click there, you can see these slides as well. So you'll have all the links. So this animation here is something I did for my master's, where we were trying to do inversion of gravity gradient data. And the method that we came up with was for like building the solution one little block at a time. So you can specify several constraints and it kind of builds the solution that way. I find it makes for a very nice animation, which is why I got interested in it in the first place. Okay, so then I also have my teaching hat, where I'm doing mostly global geophysics. I also teach a little bit of inverse problems, a bit of remote sensing, which is kind of new to me now. There's also some field work, some math, some tutorials, dissertation supervision. So and I also teach several short workshops on mostly on computing projects. So whether that is introduction to programming and a more advanced scientific computing. Most of my teaching involves computing in some form, whether it is for analyzing data, like the example there on the screen with the remote sensing data sets, or whether it is through simulations and messing around with geophysical data. Right, so it's a big part of what I do, and most of my teaching material is openly available, and there's a link there to the teaching page on my website where you can find links to basically everything I have to offer. Then my third hat is my fun hat, which is the one I try to wear underneath all the other hats. And this is where I do work on open source software. So I've been involved in open source in some form or another ever since my bachelor's degree. And the main projects I still work on today are Fatiando Terra, which is something I started back as an undergrad. And it's a collection of several different open source Python libraries for geophysical data analysis. And that's where most of my research ends up going into. I also work on the generic mapping tools, GMT, and that came about as part of my postdoc. And I built a Python interface for GMT, which is now carried on by the community, and it's been growing steadily in the past few years. And the latest addition is something called Nene, which is my side project for building websites, and it's what I use to generate my own website. So that's where really most of the fun bits happen, and it's not in the same state as the other projects because it's something I do mostly as a hobby. So also there's a link there on to my website for all of this. But that's enough about me. What I really want to know is who you are, because I don't, unfortunately, I don't already know all of you. And the SPIN network is a bit new to me as well. So I kind of wanted to get a feeling for who you are, what level of skill you have, and what interests also you have. So the way we're going to do this is through this menti.com. So I'm going to put a link to that on the Zoom chat. So please go into this link, and that'll give you a multiple choice question. And hopefully, as you start answering that, the questions on the slide here should get populated. I'm not entirely sure it's going to get populated automatically, but let's see how this goes. So I'll give you a minute to go and answer. And this is mainly what level of education are you at? So year of the PhD, or if you've already finished your PhD or you're not, then there's other there as an option. All right, so let's see if this works. Let me start refreshing the page. All right, yes, I got some answers coming in there. Okay, so right, so mostly first year PhD students. So that's, yeah, that's very good. It's a very good time to start picking up some of these open science practices, because a lot of them take a little while for you to build up and experiment with. So yeah, I'm very happy that there are a bunch of you are starting out now. And let me just refresh one more time to see if there's anything new. Okay, yeah, so still mostly first years, right? So the second question, and I'm going to put this in the Zoom chat as well, is what are your areas of expertise, right? So what do you research? What are the things that you do, topics that you research, skills that you have or that you're developing, things that you use on a daily basis? Right, and this can be technical, social, whichever any dimension that you want. Okay, so let me try this. Let me try refreshing. And let's see what we have. All right, so we got full waveform inversion, programming, rock physics, experiment design, okay. Seismic tomography, numerical modeling. We got some more coming in. Let's refresh again. Okay, so actually, let me switch up to the live view here. All right, so yeah, quite a varied bit of expertise you got there. Yeah, apparently a lot of programming, Python, very physics, numerical methods heavy, it seems. Bayesian statistics, writing. Yeah, I think as your career moves on, the tendency is that you'll be mostly a writer, and all the rest is the stuff you do when you have some time. Okay, yeah, but yeah, good spread there. Let's move on then to the third question, which is to rank your experience from, I've never done this before to, yes, I have a moderate level of experience with this for these 4 topics. So I'm gonna put a link there on the Zoom chat, and let's go with the Menti live preview. All right, so you can rank these on a scale of 1 to 5. All right, so yeah, a lot of people pretty experienced with coding. It seems like we're heavy on the more experienced side, apparently. Yeah, but a good, but also a good range going down onto the more novice side. But yeah, so it's very hard to find someone who's done no coding at all nowadays in a STEM field. But yeah, but good to see it's a very good spread there. And so for data management, I'm imagining more people, since you're all mostly new PhD students, your experience with data management is expected. It's as expected. It's a bit more limited, but you'll find this trending upwards as you get on with your PhD, and you're having to download and manage a bunch of data. Right. So paper writing. Okay. So quite a few people haven't started it, or you're progressing towards it. And okay, so also a good spread here of some experience with open science topics. Okay, so yeah, very good spread there. And for a final question, advance slide. Right, so this one you can write in, and I'm curious to see, in with regards to open science, what are the things that you find confusing or interesting, the things that you're curious about? All right, and let me switch on to this, and let's see what's going to come in. All right, open access data. What may not be open? So what are the things that maybe you can't open? I imagine that's what is meant. So what can't you do with seismology? Yeah, seismology really is like the gold standard in geophysics, and this is coming from someone who doesn't do seismology. All right, how can you make your work useful for others? Yeah, very good point there. Yeah, and a lot of this open science stuff, we do try to focus a lot on the benefit to the individual, but there's a big component of it is benefit to the scientific community as a whole, which at least for me is where I derive a lot of the drive and motivation to do my job, is from this type of interaction. So what is most of science hard to access for the everyday person? Yeah, that's a very tough question. It's definitely not a technical question or a technical matter that can be solved with technology. That's what I've kind of come to realize, which means we're veering into social science territory, which means things get really hard. All right, so how to start contributing to software libraries? Yeah, very good question, and yeah, very intimidating for people who are just getting started. Yeah. Okay, so hopefully we're going to move on now, but you know, we can keep doing this afterward. But hopefully with the things that we can talk about today and with the Q&A afterwards, we'll be able to settle a lot of these doubts and maybe point you towards finding more about the things that interest you. Okay, so for today, I prepared a few topics, and we're not going to have time to go through all of them. But you know, I put some links to resources and some an overview of each of these topics in the slides, and you can look at those later individually. But there's a bunch of options here, and I kind of wanted to let you rank which one you would like to hear about more. And we can do it in priority, in order of interest. And the things we don't get to, then there's still resources that you can see on the slides. So I'm going to put a link here. And for this one, please rank the topics that you'd most want to hear about. And the last one here, so Leo, shut up and listen, is for us to just go straight to the Q&A, and we can. You can look at the slides later on your own, right? So if that's something you'd rather do, then I'm happy to do that as well. And let me switch to the live view. All right, so we got all right, let's see if might be a couple of more coming in. Okay, I think that's everyone who's on the call now. So see, that's why this is useful. I would have gotten these in completely the wrong order if I was trying to pick them. So clear winner here for making open source software, and then we'll go to preprints and publishing data. Okay, so so let's get to it then. Let me see if I refresh this, if it works. Yeah, okay. So let's go with making open source software first. So I'm gonna click on here. Okay, so when we're talking about open source, there are a few things that tend to prop up, and people have often they already have a picture of what that means. And you might be thinking of something like, I'm going to write Jupyter, or I'm going to write NumPy, or scikit-learn, or the Linux kernel, or something big like that, like Firefox. When in fact, there's a full spectrum of things that you could do that would qualify as open source, and that you can build towards progressively, right? So no one starts off, unless you're Linus Torvalds, but no one starts off by writing Linux, right? No one starts off by making NumPy, right? NumPy came about from very experienced people who were, you know, mixing a bunch of expertise that they had on previous projects. So everyone starts at a lower level, and you build towards making something big. So I wrote here a bit like a general overview of what I would consider different levels of open source. I kind of want to emphasize that they're all important, and every single one of them is much better than no code at all, right? Because so don't feel like, unless you're on level 6 that it's not worth doing. So start off the way how you can. So the first level would be you put your code in the journal supplements, right? Then a level up from that would be you have it also on, or exclusively or also on a GitHub repository that you dragged and drop all your code onto the GitHub web interface, and then you put a little README on there explaining what your code does. Right, so that is already better than the journal supplements because it's not going to be locked behind the journal system and it's easier to discover, right? A level up from that would be that you have your code on GitHub and you wrote a more detailed README and you put some examples in there as well in case people want to try to run your code, right? And this could be the code that you're doing for the analysis on a paper. A level up from that would be also including more detailed documentation on your code, putting some contributing guidelines. So, for example, what type of contributions are you interested in? How can people change your code? And also having some form of tests so that if you do change your code, that you have a quick way to figure out if you broke it or not, right? So that is by itself, that is already a huge topic and something that's difficult to get started doing. But it's immensely valuable, right? So it's worth investing the time, in my view, at least. A level up from that would be you have all of the above, right? So you got it on GitHub with README, examples, documentation, contributing guide, tests, and you're also publishing this to some sort of package repository. So if you're doing Python, having things on PyPI, and if you're using Anaconda, then CondaForge is a good place to have your packages. Or if you're doing R, there's the CRAN, the R package repository, and there's NPM for JavaScript and so on, right? So having something in one of these repositories that can be easily installed, right? So can you Conda install your software? Can you pip install your software? Or do you have to clone the GitHub repository and try to compile your code or do whatever, right? So that, again, that by itself is a huge thing. It's not something that is easy to do. Actually, this is probably the hardest thing to do out of all of this, is writing code that works on other people's computers. So really, if you don't make it to this level, you're absolutely fine, right? This is not for everyone, and it's not something that that you get to overnight, right? This requires effort and work, basically. And the final level, which is probably where you'll find a lot of more advanced open source software that's been around for a while and has more experienced people working on it, is where you have your code on GitHub, you have extensive documentation, you have contributing guide, you have tests, you have your software in package repositories, and you also have automated testing and deployment. By deployment, I mean, when you make a change, the documentation is automatically updated. When you make a release, it's automatically packaged and pushed to the relevant repositories, right? And this is done with systems called continuous integration, right? That's what the CI there stands for. A very popular example right now is GitHub Actions. So this is built into GitHub, and you can basically tell their computers what to do whenever you push a change to your repository, right? So once again, this is also a huge topic. Each system is usually completely different from the last. So every time something new comes on, we end up having to kind of learn how to do things in the new system, which is a lot of work. But again, the benefits of this are just freeing up your time, right? So if you have all of this set up, then you don't need to worry about, did my change break my code? Is it still in the right style? Have I updated the documentation? Did I upload the right thing to this place and that place and this other place whenever you make a release? So all of these things are automated through these systems, right? And one of the ideas behind automating is that it doesn't depend on you knowing how to do things, right? So if I want to hand off a project to other people, so if I step away from a project, having all this automation lets people know how these things are done because it's documented in the automation script, right? So as a very practical example, I kind of stepped away a bit from the PyGMT project, but since we had all of this set up, it really just kept on going fine without me because we had other people involved and all the processes for doing everything was all already automated there. So a very important note throughout all of this. So no matter which level you're at, it's absolutely imperative that your code has a license because, or an open source license, because code without a license technically cannot be reused, modified, or extended, right? So putting something on a website where anyone can download is different from making something that other people can repurpose and reuse, right? That's what licenses are for. They're there to ensure the rights of the user, okay? So in terms of learning resources, we luckily live in a time where there's plentiful resources out there. The difficulty now is just finding these things and choosing from the many options. My personal recommendations for learning how to do this would be the Software Sustainability Institutes, which is from the UK. They host these research software camps that teach a variety of different skills at different levels all around research software. So I highly recommend checking that out. Most of the events are all free and they happen across the UK and online. There's, of course, Software Carpentry, which I'm sure some of you at least are familiar. So they have a bunch of courses on using Git, using GitHub, which is the platform where we build software nowadays. And their chapters on Python include a bit on the philosophy behind testing and how to make sure that your code is more maintainable. On top of that, they're piloting a intermediate software skills lesson that goes into a bit more detail on continuous integration and all this automation and packaging and all of that. I also highly recommend this website called The Turing Way by the Alan Turing Institute here in the UK as well. This guide is just amazing, not only for software, but for, you know, information on licenses, on distributing your data, on best practices for anything working in the open, basically, and collaborating. There's also the Python packaging guide. So if you're doing Python and you want to know how do you get your software on PyPI, this is a very good guide for that. And there's a more opinionated version. This is the Python packages book developed by a team at the University of British Columbia. So it's a bit more opinionated in terms of which tools they use, but it's also a very good introduction. Besides that, I would say ask for help and chat. A great place for doing that is the Software Underground. So this is a brand new scientific society. It's a nonprofit. You can register for free. They have a Slack group that now has almost 5,000 people in it. But if you're interested in the overlap between geoscience, code, open science, and data, that's the place to be. We've been doing annually these events where we produce a bunch of open video content in tutorials and all sorts of things called Transform. So there's actually a video this year on Transform about, you know, making a Python package. So I highly recommend checking that out and joining the Slack group where you can ask questions and people are very keen to help. And as a final way to really do this is, try to get involved in an open source project. And I saw that there was a question on, how do you actually do this? There's not really a secret. What I would say is, for example, look for projects that include something like this. So this is from the Fatiando website, and we do have a page on how do you get involved. And it's going to have information about, where we hang out, how do you reach us, where's the code. So we have weekly video calls that you can, anyone's welcome to show up and start talking. And that's usually how people get involved, is by just kind of hanging out online first, and getting a sense for the project. And at some point you will see something that you want to try to do. And we're always very keen to help people get started, right? And get more people involved, because that's just how we manage to sustain all of this. There's also a link here to PyGMT that also has an extensive contributing guide. Generic Mapping Tools itself also has a forum, and so pop in there and ask questions. Or if you see something in the NumPy documentation, for example, they have guides for how you can contribute. And we're always looking for things like, a great way to get started is, fixing a typo here, fixing wording in the documentation, adding an example, things like that are great ways to get started. All right. Okay, so let's go back to the topics. And the second one was preprints. So let's do this. I'll do preprints, and then I'll go with publishing your data. And after that, we can go straight to just an open Q&A. Would that be okay? Yeah, okay. Saw some nods. Okay. Right, so let's do preprints then, which is the second topic. Okay, so preprints and postprints. So this is something that has gotten quite popular lately, but it's also like the terminology around all of this can be very confusing. So let's start off with some definitions, right? So a preprint is a version of a paper that has not undergone peer review yet, right? So as soon as you're done with your manuscript, when you submit it to a journal, that version that's going to get reviewed, that's the preprint. And this is something that you can submit to a preprint repository. Oftentimes people will do this at the same time that they submit to a journal, right? So people can read the pre-review version while it's still undergoing peer review at a journal. So the main advantage of this is start getting the word out from your paper, and perhaps getting feedback from your community about your science, right? So having the preprint lets other people read it, and not just the 2 or 3 reviewers that the journal invites, right? So you can often get feedback on this early version that you can then apply and improve by the time the paper is actually out. So think of it as like crowdsourcing peer review in a sense. Postprint, on the other hand, is the version of your paper that's gone through peer review, but before it's gone through copy editing. So copy editing is the process of getting the text and the figures and the math into that like neat little journal PDF, right? So it's the same text, same figures, but before the journal editors have had a go at it and try to make it pretty. Oftentimes you'll submit this to a repository after you've gone through journal peer review, so that you can make the reviewed journal version of your paper available. If you're, for example, if the journal that you're publishing in has a paywall, then this is one way that you can circumvent that paywall and make your paper open access without having to pay the exorbitant fees that some journals charge. You need to bear in mind that there may be an embargo on when you can post your postprint, and this varies by journal. So where can you publish preprints and postprints? There's the Earth Archive preprint server. This is relatively new. It only came about in the last couple of years. And this is entirely managed and run by the community, right? So it's a bunch of geoscientists from around the world that got together. They made this thing. It's hosted for free on the California Digital Library. So they donate the funds that we need in order to register DOIs and store all the papers and do all of that, and the submission system and all that. So this is independent from any scientific society, from any journal publisher or anything like that. Another option for geoscience specific things is SOR. So this is the AGU preprint server. And as such, it is actually run by the publisher Wiley, as is all the other journals that AGU has. So this one is not, while it is managed by AGU, it's not really run by the community. So there's pros and cons that come with that. Then there's also the archive, which is the original preprint server. This is hosted at Cornell University, and it's mostly dominated by physics content. So physics, astrophysics, astronomy, all of that. They post very heavily there, but there's also a geophysics section, and you will see usually more math-heavy artificial intelligence guided papers on archive. So that's another option that you have. So another question you may have is, why would you do any of this, right? For me, the main reason is you get open access for all of your output on the cheap, right? Or for free, mostly for free. So it's a way of making your papers available for everyone at no cost, and without having to pay usually the large article processing charges that a lot of journals charge. So if you have a PDF, a preprint, or a postprint in one of these servers, Google Scholar tends to index them, and it'll put a link to the PDF when people find your paper, right? So it's a pretty easy way for people to find the PDF, even if they're searching for the paper on Google Scholar. There's also something called the OA button, which is a plugin you can install in your browser. And when you're visiting a journal website, it'll pop a little icon if it finds a preprint somewhere that you can read. So you can just click on that and it'll take you to the PDF. It's very convenient. I highly recommend it. And a final consideration here is, can you publish a preprint? Now, this is where things get tricky, and this is where I have to say I'm not a lawyer, so don't take this as legal advice. But in general, you have to check the journal policy, because this varies from journal to journal. So there's kind of no way around it. One easy tool for you to at least start checking the journal policy is this Sherpa Romeo online tool. So if you go to this link, it'll take you to this website, and you can search for the journal. So let's say geophysics, right? And it'll give you information about geophysics. So this is the SEG journal, and it tells you what you can and you can't do, right? So the submitted version, which is would be a preprint, it says that there's no embargo. You can host it on your personal homepage, and there are these conditions. Then there's something about the accepted version, and the published version usually means the PDF that the journal generates, right? So there's restrictions and embargoes and stuff like that for each journal. So the Sherpa Romeo lets you browse for all journals without having to dig through all their documentation. So once you've checked the conditions, then you basically just go to Earth Archive or SOR or Archive and make your submission, right? And most of these will have some form of moderation. On a personal note, I would highly advise talking to all your co-authors as early as you can if this is something you want to do, and just make sure that everyone's on board from the start. Okay, so back to the topics, and the final thing was publishing data. All right, so in terms of publishing data, one question you may have is what you could publish, right? So what sort of things can you publish? And the main thing would be original data that you collected, right? So if you're doing field work or lab work, you will generate data. And since that is generated by you in your lab, then that's something that you can publish. Or if you're using existing, and the FAIR acronym there is defined in another slide. But if you're using existing open data that you modified, and if the data license allows you to do this, then you can also publish your modified version of the data, whether it's a curation that you did of just joining a bunch of data sets and standardizing them, or maybe you calculate a derived quantity. So like you take a bunch of seismic data, you make receiver functions. So yeah, you want to maybe publish the receiver functions. So where can you publish? Again, as with preprints, there are many data repositories out there nowadays. Most of them will give you a DOI, which is a stable link. So a DOI is a link that's kind of guaranteed to go somewhere. It's not going to be broken, right? And that's why DOIs are used for citation, because your personal homepage, it could be down tomorrow. GitHub Microsoft could decide to shut it down at any time. And so it would be very frustrating if you get a paper a couple of years from now, there's a link to the data, but the link is broken, right? And this very often happens if it's an FTP link to some website somewhere, which is one of the reasons that you want to get a DOI for your data set. The main one I would recommend trying out is this one called Zenodo. So this is managed by CERN. And it was originally created to host all of the LHC data that was being produced, the Large Hadron Collider. But it's open, anyone can publish there. They have a limit of, I think, 50 gigabytes per data set, but you can request more storage if you need it. So they're very open, very friendly, and it's very popular for putting data out there. Another one is Figshare. So this is a commercial platform, but it is free up to a certain limit. I do like it quite a bit. You can post all sorts of things there. It gives you a DOI, a citation point, and it tracks views, downloads, and citations as well. So yeah, it is also quite handy. There's also one called Dryad, which is a nonprofit, but it's a paid platform. So you pay a processing charge for submitting your data. And they have deals with certain institutions and journals where the journal institution pays, so you don't have to. And finally, there's one called Pangea, which is run by some German institutions. It's also free, and it's domain specific. So it only has Earth and environmental and life science data. So it has a very big catalog. The data is curated, and you'll find data associated with papers there quite a bit. So why would you want to publish? Mainly, I would say so that others can easily find, reuse, and improve your data. But also, if they do that, they'll likely cite your data. And if you ask them to, probably cite the original paper as well. So this is a way for your work to get known and help others build on your work. So this sort of stuff can often generate collaboration opportunities and things like that on an individual level that maybe you wouldn't get otherwise. For a more altruistic view, you can think of it as, you're contributing more than just the words on a PDF to the scientific enterprise, which is also, not an insignificant thing. So if you want to publish your data, same as with preprints, first, make sure all your co-authors are on board, and do this as early as you possibly can. Then choose a license, and there's a link here to the license explanation slide. So click in there and go have a read. Then you upload it to the repository of your choice. You can do this at the time of submission of a paper or after the paper is accepted. Most of these will let you reserve a DOI. So you can already cite the DOI on the paper before you release the data. That way, when the paper is published, there's a DOI link to the data set that is kind of guaranteed to always go to the data set, no matter what happens to the platforms involved. Right, and that's it. So there's really not a whole lot to it. the main thing really is, talk to your co-authors and choose a license. Okay, so with that, we're kind of running out of time. So I'm gonna skip ahead here to the end. So there's a bunch of resources out there that links in the slides, but I just wanted to go over a few of the main takeaway points. So one, yes, it is scary to do things in the open, but it's also incredibly rewarding. For me, at least, any code or data is much better than no code or data at all. So whatever you can put out there, it's already more than none, which is great. If you do this, make sure that it has a license. So publicly available is very different from people can actually do things with the things you're publishing. Everyone's code is ugly at some point, right? So everyone's code starts ugly. So don't let ugly code be a reason for you not to publish. On that note, start where you are and do what you can, right? So don't wait until things are perfect. Don't wait until next time, because next time you'll have more time. Next time you'll be better. It's much better for you to publish now and then improve for the next one, right? For your next paper, you do better. For the next paper, you write cleaner code. So think of it as building towards an ideal and not really already being at that ideal so that you can get started. To get there, I would recommend, researching what other people do and emulate the good practice that you see. And when you do see good practice and you're emulating it, pass it on, right? So for things like this, talk to the other PhD students in your cohort, the ones who are coming in next year who maybe you will have more experience that they do. So, pass it on and, everyone gets better that way. Then read the Turing Way. That's an awesome guide. You don't need this talk, just read that document. And join the Software Underground if you want to keep in touch with the community. Right. So with that, I'll wrap things up. We've gone a bit over time now already, and I wanted to leave more time for the Q&A. So sorry about that. But there's my website. It has contact information. You can find me all sorts of places, and I'm always happy to chat. So thank you.
So first of all, thanks a lot for the talk. And let's start with the questions.
Yeah, all right. Hi, great talk. I really enjoyed it. Also enjoyed the Mentimeter stuff. It was awesome to see. Yeah, one question. If you're putting your data on a repository, what would you advise to do? How would you advertise this? How would you put this information out there? I mean, the data is no use to anyone if it's just lies there in the repository and no one finds it because no one's looking for it. So yeah. How would you do this?
Yeah, that's a very good question. The main way I would recommend is cite the data in the paper that's usually associated with the data. Right. So if you collected a bunch of data, you did some processing, you generated some outputs, and this is going to be part of a paper at some point. So the most likely users of that data are the people who are reading your paper. Right. So if you publish it and you get a DOI link that you then include in your paper, for example, in a data availability section that's encouraged now in a lot of journals, then people can go to the data afterward and use it. But besides that, share on social media, share on Software Underground or places like that. And if you're doing any sort of software work, then using the data as example in your software, that's also a big way to publicize the data sets. And that's why also having a license that allows free reuse of your data is very important, because as a software project, I'm not going to take some random data from the internet and put that in my software if there's no license explicitly saying that, yes, I can do that, right? Because otherwise I would be risking liability, especially if it's as supplementary information in a journal article. I doubt that any author would ever want to sue anyone for using their data, but I wouldn't put it past a publisher.
Thank you.
Yeah.
Then I also have a question. Maybe taking it from the other side. So we now use increasingly more open source packages. And how do you make sure to give them the appropriate credit? For example, most of the times in seismological papers, OPSPy is cited. But of course, OPSPy uses NumPy, which uses some methods that are from another paper. Like, how do you give the right credit to the right people? But how do you, like, where to stop and at a decent point?
Yeah, that's a great question. Yeah, that matter of where to stop. I mean, we face that even if you just disconsider code entirely. Whenever you're writing a paper, you face that question, right? So if I'm doing something in gravity, like where do I start? Do I start by citing Newton, or do I just assume that, you know, we can start off from a certain level of understanding? And I feel like the same thing applies to software. So you could, you know, if you're going to take the approach of I'm citing every single bit of software I used, then do you cite your operating system, all of the drivers that you use in there? Do you cite the web browser that you were using to run Jupyter on? So where does it stop? And that's very tricky. My personal approach has been to cite everything that I use directly. So if you're using OBSPy, it's very likely that you're also importing NumPy, right? Because, you know, the OBSPy doesn't do everything, right? You also call matplotlib to compose the figure. You also call NumPy to calculate a mean here or there. So yeah, my personal approach has been I cite everything that I import directly in my analysis code.
Okay. Thanks
yeah, but again, like if you feel like, you know, you should be citing NumPy, then yeah, by all means cite NumPy. You know, most of the time citations are free. It's at least I've never encountered a journal that said, no, you have too many citations. You know, we can't have a 20-page PDF.
Okay, thanks.
Yeah, can you, sorry, yeah, can you think of an example where authors really got into trouble because they already published something as preprint, and then the journal would just not allow submission, or?
I don't have any anecdotal examples. But if you look at some of the preprint policies, so for example, the one for the geophysics journal, it does say that they only allow preprints if it's on your personal website. Now, whether if I post it on Earth Archive, whether anyone in the journal is actually going to go and check if it's there and then say, no, you've already published this. I don't know, honestly. I do find it kind of unlikely, but you know, I'm not a gambling person, so I wouldn't bet on it, and I maybe wouldn't take the risk. If you absolutely want to publish in a journal that doesn't allow preprints, then yeah, so maybe don't go with a preprint. But my personal strategy has been to only search for journals that explicitly allow preprints. But you know, it's always better to err on the side of caution, I would think. Especially with something like a paper for your PhD, that's not the kind of thing you wanna mess around with.
Oh yeah, definitely. Yeah, thanks.
Oh, sorry, Celine. I can't hear you. You do seem to be unmuted, but there's no audio coming through. You can type it in the chat and we can read it out loud. Yeah, does anybody else want to ask a question in the meantime?
Yeah, maybe a question in general about open access data. Yeah, because sometimes you work in projects or you collect data which you cannot directly distribute or put online because of the project, or the data was like really expensive to make. And sometimes for some specific data structure, this also means that some of the code is reliant on the data. So the code by itself doesn't have a strong meaning without the data attached to it. So what you can do in that case, or is there nothing to be done in that case?
Yeah, that's very tricky, because sometimes you're right. You have proprietary data that maybe you got from a company, or that was part of some consortium, and you can't just share it. But if you can share the code, even if it's deeply tied to the data, there's probably details in the code of how you got your results that probably aren't described fully in the method sections of your paper. At least that's often the case for me. Whenever I'm trying to reproduce a paper, there's always some little detail that I have to put in my code when I'm trying to reproduce the paper that wasn't in the methods, because it's very hard for you to fully describe everything. So I would say that if you can publish the code, then publish the code. If you can't publish the data, then it happens. Sometimes there's nothing you can do. After you already have an agreement for acquiring the data that says you can't publish, there's really nothing you can do. Or maybe you can try to reach out to the people responsible for deciding whether or not you can publish the data, and try to make a case for publication of the data, perhaps in an anonymized form. So in geoscience, I'll often see people removing coordinates, for example. So there's a data, but you don't really know where in the world it applies. So that kind of, lets you do your science, but maybe remove some of the, let companies retain their commercial advantage. Or you can try to word, if you're coming up with a new agreement for collecting new data, then, maybe bring it up in the initial discussion that, yes, this is a scientific endeavor. If you're funding a scientific endeavor, you have to be committed to publishing the entirety of the research. So that's something that you can try to do as part of a publication, or as part of a collaboration agreement, for example. Right, but once it's established already, and if they already say no, that they're not going to change it, then there's not that much you can do. But this is an evolving thing, right? It's a tricky problem. Especially when you're dealing with things like that are petabytes in size. You can't just upload a petabyte data set to Zenodo. And so that's kind of where the frontier lies. But also, that's not where 99% of people are. Most people have a moderate amount of data that they could probably upload. Yeah. I see we got the question on the chat. So do you know what typically happens when a preprint has already gathered citations and the paper published in a journal gathers additional citations? So are there ways to combine them? Yes, unfortunately, the system judges us on citations. Yeah, that's very true. So this really depends on the platforms that are being used to track citations. On Google Scholar, you can manually merge, or actually it might do it automatically. So you can merge publications into one. So for example, if you have the preprint and the the final publication, you can ask Google Scholar to merge them and count them as one. So that'll boost things like the H-index that it calculates and citation count for that paper. And I think you can also do this in platforms like Scopus or Web of Science, Researcher ID. But if it's a university that's trying to judge this on a university system, then you would have to check if they have a mechanism for you to merge citations. But yeah, this is a tricky problem. It's not something that happens automatically, unfortunately.
Maybe my sound is fixed now.
Oh, yes.
So, yeah. Okay, great. Yeah, thanks for that. So do you know whether there are some efforts in the community, let's say, to try to motivate universities and these bigger platforms to combine citations automatically like that? Because there seems to be a push towards open science more and more, also from the funder side of things.
Yeah.
So that means that has implications on how, let's say, the system deals with all these metrics that have been invented.
Yeah, for sure. Sorry, go ahead.
Do you know if there are any developments there to say, let's say, support open science?
Yes, there are. I'm trying to remember the name of one that I had seen recently. Oh, here we go. So it's called OpenAlex. I'll put a link to that in the Zoom chat. Right, so this came about from the same people who develop, so it's a company called Our Research, and they are the ones who developed things like what was it called, Impact Story. So they've been working on this space for a little while, and OpenAlex is their latest thing. So this is a catalog of papers and all the metadata that's associated with them, and that includes citations. And the idea is they make this available with an open source API with a web interface. So it would be kind of like a centralized thing that can merge citations and do things like that, and other people could rely on them, because the main problem right now is that the institutions gathering these citation data, they're not really working together. So it's not a centralized thing. It's not a unified thing that tracks citations. It's all a bit of a mishmash. And so that's why you get different citation counts on Google Scholar versus Scopus versus some other systems.
Okay, thanks. Yeah, looks interesting.
Mm-hmm.
And I'm wondering how many of those systems are also taking into account citations for data sets and software. I guess that's also becoming more and more common to keep track of those as well.
Yeah, so things like for software and data, I'm not sure about OpenAlex. I know that Google Scholar does track some repositories, and if you have things on your ORCID, so the identifier. So for example, if you push a archive of a software release, choose Zenodo, and you, as an author, if you have your ORCID in there in the Zenodo metadata, it does automatically feed into your list of publications as a software archive. So that's basically what I've been doing. And then the University of Liverpool system here has an automatic import from ORCID, and so it gets populated with all of the software releases and data set releases. So you can get some credit for that, but in terms of citations, it's a bit it is a bit trickier because it depends on the indexer counting citations. Yeah, but I feel like it's only a matter of time at this point, because it is kind of going very much towards that route.
Yeah, I guess that gives us a good reason to already get started with giving credit where credit is due, and also associating your own output with these DOIs.
Yeah, the earlier you can, yeah, If there's a trend in the community that you're seeing, the earlier you can get on it, the better, because there's a very big effect of being an early adopter in these things, rather than just chasing and try to compensate for lost opportunities later on. It's just I find it's the same thing with learning how to code and being more data driven. Like nowadays you kind of have to do it, right? If you don't put machine learning in a proposal, it doesn't get funded. And so there's so many people getting started now that now it's kind of a crowded space, whereas if you spotted this trend 5 years ago, which was clear 5 years ago that this was the trend, so the people who jumped on early on, then they're the ones who are getting the most out of all of this. Right. So as early PhDs, like keep an eye on what's going on, right, in the broader community. So try to be plugged in and pay attention to these large scale trends. And since you're carving out your niche in the scientific world, if there's anything that you're passionate about and that you spot as a trend, because there's no point in jumping on a trend just because it's a trend. If you're not passionate about it, life's too short for that. But definitely, like if you see something, then grab on and try to align your passion for something with an emerging trend. That's a very powerful thing.